This is problem number 30, and it's a fairly straightforward problem once you understand what you're being asked to do. So we were given this fund of 120, we're going to call it dollars. There's 20 employees. There's a 2% chance that any one individual employee is high performing. And then there's independence between each individual employee. So that right there is what signals us that we're working with a binomial distribution. That's the easy part of the problem. The challenging part here is this C dollars paid that we're trying to figure out. It says, calculate the maximum value of C for which the probability is less than 1% that the fund will be inadequate to cover all payments for high performance. So what we're being asked to do here is find the cumulative probability of our binomial distribution up until we get to just slightly more than 99%. And then that remaining little bit less than 1% will be the probability that we don't have enough money in the fund if we select the value of C as I'm going to demonstrate here. So that's enough preamble. This one is a great problem for the table feature of your calculator. So we're going to use a binomial distribution, 20 choose x times 0.02 raised to the x times 0.98 raised to the 20 minus x. And I'm going to write out the first few values that are going to show up in the table. So supposing x is equal to 0, that is 0 employees reach the high performing standard, then the probability of that outcome is about 2/3. So 2/3 of the time, nobody gets the bonus. And this corresponds to a value of C that's kind of meaningless. If nobody gets the bonus, then we can set C to whatever we want, but it just doesn't matter. So if one employee gets the bonus, this is somewhat likely at about 27%. And here the value of C would be equal to 120. But notice the cumulative probability here. If we add these two values together, we get 94%. So right now there's a 6% chance that if we select $120 or answer choice E, there's a 6% chance that we're not going to have enough money in the fund. So let's check out 2. If 2 employees win or rise to the high performing standard, there's about a 5% chance of that. And this would be C is equal to 60 because we're going to split the fund between 2 employees. And now cumulatively, if we add the 0.528, we get to 0.9928. So at this point, there's a less than 1% chance that we aren't going to have enough money in the fund if we set the value of C, the amount that we're going to pay each employee, to $60. And you can run through the remainder or a few others if you want, just to get a better sense of the context of the problem. But the probability of 3 employees, very unlikely. And it's sort of clear that it's less than 1% at that point. But the value of C would then be 40, but we're asked for the maximum value of C. So while this would satisfy the conditions that we could choose, we're asked to find the maximum value of C. So this is the one that we're going to go with here. So simple calculations, a little bit more challenging on the sense-making side here with this problem.